Hi. Now let's continue and focus on the major anthropogenic source of air pollution, which is combustion of fossil and non-fossil fuels. Combustion means burning, and burning is a fast oxidation process which produces heat. The fuel that is burned can be solid, for example coal or wood or waste of some kind. It can be liquid, for example oil, or it can be in gas phase, natural gas or biogas. And combustion emits now both gaseous and particulate pollutants, which we will now go through. But how this happens? What happens when we heat fuel? Now we mainly consider first the solid fuels, for example wood. When the fuel heats, some of the organic compounds included in the fuel, an organic compound now meaning carbon-containing compound, these organic compounds become volatile. They evaporate, which means that they turn to gas phase molecules. Like water, when you heat up water, it at some point then starts to evaporate and form vapor molecules. Same happens for some organic compounds in the fuel. Additionally, when the temperature goes well beyond 100 degrees Celsius, some of the carbon compounds in the fuel may break down due to the heat, and the outcoming compounds are typically more volatile than the original compound. This also causes evaporation of these outcoming compounds. As a whole, this process of carbon compounds evaporating from the fuel while heated is called pyrolysis. And the compounds that are evaporated this way, they contain a huge variety of different molecules. Now when the gas molecules have been evaporated when they flow out from the fuel, if the temperature is high enough and there is enough oxygen, these gaseous organic compounds may burn. And this burning we see as a flame. So flame is burning of gas phase molecules. If the gas molecules are burned incompletely, there's not enough oxygen or the temperature is not high enough, they can form agglomerates, meaning chains of partly oxidized molecules. And these agglomerates are called black carbon. These black carbon agglomerates are from, let's say, 10 to over 100 nanometers long, and they are not anymore single gas molecules, and thus they are considered as aerosol particles, and they are particulate pollutants. The same burning of gas molecules, of course, happens also in combustion of gas phase fuels, for example, methane gas. But now, not all the evaporated organic molecules burn in the flame. So what comes from those that escape the flames? Those that were evaporated simply because of increased temperature, they typically become condensable immediately again when they cool down. And when they become condensable, they tend to condense on any particle surface they meet. For example, the black carbon agglomerates I just described. And when they condense on these surfaces, they form organic carbon. Organic carbon is the term describing the carbon molecules that have condensed on particular surface. And the organic carbon is typically a very important part of the smoke we see. If there's no organic carbon, we typically see very little, if any, smoke. Then those are gas molecules that were formed when heavier molecules broke up in the heating process. They can be emitted as VOCs, volatile organic compounds. Also, these VOCs can then later on form organic carbon after some atmospheric processes that make them condensable, but this does not happen immediately and it typically does not contribute to the smoke formation. Now we have produced organic gas phase compounds, VOCs, black carbon, and organic carbon from the combustion process. But they can also oxidize further. If the temperature is high enough and if there's enough oxygen, the oxidation cuts the carbon chains in the gas phase molecules and in the black carbon agglomerates, as well as in the organic carbon. And this oxidation forms now carbon dioxide. Carbon dioxide is the product of complete combustion, fully oxidized state of carbon. It's a greenhouse gas, but typically not considered as an air pollutant, and only in some indoor conditions carbon dioxide concentration is taken into account when looking at the air quality. Now, if there's not quite enough oxygen for oxidizing all the carbon until carbon dioxide, some part is also emitted as carbon monoxide, CO. And carbon monoxide is now considered as an air pollutant, as it has harmful health effects. Okay, now we talked about outflowing gases or gas phase fuels that burn, but also the solid fuels can burn. So not all the fuel is typically evaporated. For example, charcoal and coke are solid fuels from which the volatile compounds have been removed with pyrolysis in the absence of oxygen. So the volatile compounds have been evaporated from the fuel. What is left is only the solid fuel. And now when these solid fuels, coke or charcoal, are burned, we can see a glow, but no flame, as the gas molecules have been taken out. And also this burning of the solid fuel emits carbon monoxide and carbon dioxide. But there are also non-carbon emissions from carbon fuel combustion. Practically all carbon fuels contain some sulfur, if it's not specifically removed. When we are burning sulfur-containing fuels, the sulfur is emitted as sulfur dioxide, SO2. SO2 can form in the atmosphere or already in the emission sometimes sulfuric acid, which is a very condensable vapor. And sulfuric acid can form new particles, particulate matter, directly from vapor molecules. Vapor molecules colliding with each other can form new particles when sulfuric acid is involved. Also, nitrogen oxides are formed in combustion processes. It can either be oxidation of nitrogen that the fuel contains, or then combustion of atmospheric nitrogen molecules, N2 molecules, in the high temperature, high oxygen concentration. They can be also oxidized to NOx. And then there are impurities with smaller concentrations in fuels, for example, some metals. The metals can form small clusters of only few nanometers in diameter, and this happens often, for example, in road transport emissions. And the metal and sulfuric acid clusters, they form cores on which other vapors can then condense and form more particulate matter in forms of sulfate from SO2, nitrate from NOx, and organic carbon from the volatile organic compounds. And finally, a secondary gas phase pollutant, ozone. In stratosphere, ozone is formed naturally, and it protects all the living tissue here on the Earth by protecting the tissues from UVB and UVC radiation. But here in the lower troposphere where we live, ozone is considered an air pollutant. It's produced when sunlight reacts with NOx, VOCs, and carbon monoxide and methane. And these processes produce photochemical smog, which will be discussed later on in this course. So as a summary of combustion emissions, combustion emits carbon-containing pollutants, gaseous pollutants, carbon monoxide and volatile organic compounds, as well as inorganic non-carbon compounds, sulfur dioxide and NOx mainly. These compounds can form directly in the flame or after that particulate matter, and also one part of the particulate matter is the black carbon agglomerates formed in the flame. Additionally, carbon monoxide, nitrogen oxides and VOCs, they produce ozone when reacting with sunlight. And ozone production and particulate matter production are the big issues for the air quality currently and in the past and in the future.